So for example, 5, determine the initial acceleration of the 10 kilogram smooth color. The spring has an unstretched length of 1 meter. Okay, so first things first, let's write the given. The given is the mass of the color. Say this is M, 10 kilogram. Okay, the stiffness, 10 Newton per meter. And the initial length of the spring so the deformation is initial minus final minus initial, so its unstretched length L0 is 1 meter. But as shown, the spring is stretched to 5 meters because 3 squared plus 4 squared is 25. Square root of that is 5. So that's the final length. It is stretched to 5 meters, such that the difference is 4 meters. That is the displacement. This is the displacement, 4 meters. Okay, so continue. Required initial acceleration. The acceleration. The initial. Initial acceleration. Does it imply that the acceleration of this smooth color from this point, let's say it's point A to point B? Sorry. Let's do something better. From this point, let's say this is point A and this is point B. Does it imply that the acceleration of this smooth color varies or changes from this point, from point A to point B? Maybe. That's why the question is just the initial acceleration, the point, or that time at which the body starts to move. Okay, so for this solution, first let's analyze, of course, the free body diagram at this instance. At this instance, what are the forces that act on this smooth color? Number one is, of course, the spring. Okay, so if we draw a separate free body diagram, first we have, of course, we have the angle here. It's called theta. There is a force here, friction, spring force. Let's call it Fs. And of course, there is a weight. And there is also a normal force because there is a common surface between the color and this rod member. So there is a normal force, and that normal force is perpendicular to the surface, and that is the reaction to the weight. Okay, so this is our x, this is our y. So these are all the forces that act on the smooth color. Since it is smooth, there's no kinetic friction force. So at this instance, these are the forces. So I now get why the question is the initial acceleration, because the normal force and the weight are constant in magnitude except for the Fs. We know that Fs, spring force, is itself already a variable because it depends on the displacement S, which is the 4 meters here. And aside from that, there is also another factor which varies its magnitude, which is the cosine of that Fs. So Fs is a varying force. That's why the question is the initial acceleration, because when the color is halfway, for instance, here the Fs component is different, so the acceleration is not constant. So it is in the category 2, category 3. The acceleration is variable. Maybe we can add that one. No, aside from answering the question, which is the initial acceleration, maybe we could say derive what is the acceleration equation for this type of constrained motion. Maybe after this maybe after finding the acceleration. Okay, so let's first solve the initial acceleration. So again, the next step is to formulate the equation of motion. So first I'll go with Fy. It is static, therefore n is equals to W. Next we go to Fx, which is dynamic, max. So the forces that act along the x is just Fs. Oh, sorry. In Fy there is n and W and Fsy, before I forget. So Fx, here we have Fsx. That's the only force that acts on the x direction. It's equals to max. Okay. So transforming this one, n is equals to W plus Fs, which is, of course, Fs is Ks. Ks, y is sine theta. Sine theta. Here we have Fs, which is, of course, Ks, and x component is cosine theta is equals to max. N, W, sine theta, cosine theta. There are so many unknowns. But we okay, so let's try to transpose W. This would be N minus W is equals to Ks sine theta. Okay, equation 1, equation 2, let's divide these two so that Ks sine theta divided by Ks cosine theta is equals to N minus W divided by max. So this would result to tangent theta is equals to N minus W max. We know the angle theta, which is 3/4. N minus W, we know the weight, max. So there are only two unknowns left, which is the N but N can be solved from here because W is given, K is given, S is also given, and sine theta is of course given. Actually, we can solve AX from here. So we just solve it here. K is 10 Newton. I'll just write here, maybe here, 10 Newton per meter. S is 4 meters. That's the delta, that's the displacement, the change in original length and the final length, 4 meter. And cosine theta, since this is 3/4, cosine angle is 4/5. Okay, cosine angle is 4/5 is equals to m is 10 kilogram, and of course the acceleration x So we have Newton divided kilogram, that would be meter per second squared. So 10 times 4 times 4 over fifth divided by 10 is 3.2. So that is 3.2 meter per second squared. So that is the, so AX is 3.2 meter per second squared.